Hi there. Today I wanted to share my way of doing this kind of simulation, the grow effect with TyFlow. With this approach, you can have infinite amount of variations of the same tree by just changing the seed. And let's roll. Before doing anything complex, such as tree structure, I always like to break it down to the simple things. The tree consists of bigger parts that we can break down. The trunk, twigs, leaves, branches. So we will try to simulate all these parts separately. And specifically for the leaf, we will use the whole leaf blade and the petiole part, the part that connects the leaf to the branch. So let's begin. First, we create a TyFlow object. Open the editor and I'm requesting the license. So first, let's drop the birth operator and let's birth one particle. At frame 0, we need only one, and let's make it visible better. Large dot, and let's change the color for something more prominent, more vibrant. We have to move our particle up by z-axis. We can do it by simple speed operator, and from default random 3D direction we will switch to particle z axis, and as you can see it moves up for some distance. We don't know what distance it is now, so we can specify here in magnitude. So let me change from meters to centimeters, and let's say, so in 100 frames my particle is moving by 1 centimeter each frame. We can verify this by just measuring the height. I'm creating the box, and if it's 1 centimeter per frame, it means that the whole height should be 100 centimeters. That's correct. So that's 1 meter. That's kind of small tree, but this is okay. We don't need something huge. We can make it 1.5 meter. So we have to build the spline. Let's create a spline path operator, and let's create the spline. That's a good start, and but of course we are missing branches now. So we have first main trunk. Let's create the branches. We have very convenient operator branch, and it creates automatically for us all these branches. Of course we can and we have to adjust this. So let me bring my reference here. I want to create something like this. As we can see, the down part, approximately 1/5 of the whole height, is missing any branches. So we should start to give birth to those branches a little bit later. To make it possible, we will just offset the timing. In the timing tab, in the instead of continuous, we change to frame, and we specify from which frame until which one it will the operator will work. So in my case I will put 20 maybe, and only after the 20th frame branches start to grow. I think that's fine. What also we could adjust here, let me close this timing, and we can change the depth of the branches. What it means, let me just change maximum depth from 1 to 2, and you see how it creates a bunch of springs here. That's looking cool, but maybe that bit overkill for us. So we have to reduce the amount of branches here. How can we do that? We can change the distance from 5, let's say 10 centimeters, and we just specifying after what distance we want to be our branch branched out. If I increase the distance, less and less branches will be grown. Let's go something like 7 maybe. And the density I think is okay. So if you take a look closer here, you see how our branches are a little bit offsetted from the main trunk. We can fix that first of all by putting branch operator above the spline path, and then in the spline path we can enable the process at the end of the time step, and it will automatically jump into the initial position from where the when the branching is starting. And that's true for every other frames. So having this, let's introduce a little bit of noise, because now it is 2CG, 2 straight structure. So to introduce some noise, we will just use force. And in the force itself, we will not use anything else, but we will use the noise here, built-in noise. Let's just put 0.1 for now and see what's gonna happen. Well, that's of course too much. Let's reduce it to 0.5, and the scale can be smaller as well, something like that. I would make it even smaller. Yeah, now we have a little bit of randomness. So you just have to play with these settings to find the nice looking structure. I will stick to this one just in sake of timing. And having all this, we can already give it a thickness. So let me untick the display. We already created a spline with this operator. So this spline you can see in the Scene Explorer, TySplines, and if you enable TySpline Measure, you will see this shape. That's a too large thickness, the radius, so we'll just reduce from 10 centimeters to something smaller, 0.5, but they all are same thickness, and it has no thinner end part. This part should be thicker, right? If we check our reference, the trees working like this, branches always thinner. So we can change the we can enable multiply by node radius and multiply radius by length. Invert, and now we see that the older the spline, the thicker it is in comparison with the new ones. So let's grow further, and the new branches, as you can see, they are much thinner. Let's also add the curve, because this way we will have not equal radius at the end, at the beginning and at the end of each spline, and that gives that realistic effect. So, but the main trunk is too thin, I think now, so we'll have to adjust this. I found this way that if you change the maximum multiplier, we can keep it 1, then we can change the length threshold to some bigger number. Yeah, like this, 200 for instance, and then change the radius to something like 3 maybe, and then increase a bit this value to maybe 300, 500, no, let's keep it 300 and maybe play with the max and minimum multiplier. It might work. Let's put 2 here. Yeah, I think that's balanced now, more or less. And we have our base, we have the trunk, the branches. Now we're missing the leaves, but leaves are not growing straight from the trunk, from the branches. It has this petiole micro branch, let's call it like that. So let's create this part. To create this, we are gonna use spawn operator. I will spawn particles, but first let me move my time slider to the beginning, and now spawn. And for the spawn operator, I will use per frame by travel distance, and step size 1 centimeter. I will change to, for now, to something like 3. Let's see how it will work. Yeah, we need to see the dots, of course, and I will create a new event for this spawn to see the newly born particles. For the spline, I will temporarily disable the thickness just to have clear view of what I have. Yeah, and in the spawn operator, I need to change from timing to from on event entry to continuous. Not exactly what I want, so new particles have been born, but I need to keep them on the same position. So I want to scatter particles on the branches. We can do it by going to, in the spawn operator, going to position, sorry, not position, the inherited properties. And in inherited properties, we will change the velocity from 100 to 0. It means that we're telling newborn particles to not inherit their parent particles, which are green, their velocity. It means that they will stay on place where they had been born. Let me just change the color to see them better. And large dots. All right. So these are the places where we gonna build our PTO. I always forget this term. Maybe we should increase the density by just in spawning, changing the distances, close timing, and step size from 3 centimeters. It can be 2 or even 1. That's fine. And of course, we don't need leaves on the main trunk down there. Again, checking our reference. Yeah, it's missing the leaves. It means that we need to remove these points from here. How can we do that? We can simply adjust the timing. I want these particles to be born in frame from the frame 30, for instance. So in here, spawn, in timing, I change to frame and put in here 30. So from the frame 30, it will start to scatter the particles. I maybe change from 30 to 50 to keep this central part a bit bold. So maybe even 70, something like this. And we can add some variations. Why not? Yeah. So having these particles born, we can spot here one thing. So these particles are born after our spline. We don't have to do this because it means that our petioles and leaves will grow not on the branch but separately. Let me reduce those. We can do it again with the timing, changing. So we have 99 frames is the last frame. I will put here 98 and yeah, and the variation will spoil this, so variation should be 0. And the last particle had been deleted. That's fine. We can add randomness the other way. For example, we can in the particle count we can change spawn 100 particles to, let's say, 90, and some particles will not be born. Let's give it 20, and as you can see, not every branch has particles. So let's put maybe 50. To add some randomness, we can also in the distance change the variation percentage here for, let's say, 20. Some particles will be skipped. 40. All right. Now what I want to do is to born more particles from these. So let me add here again the spawn operator. Move it to the new event. And as you can see, these particles already been born, but they are now sitting on top of each other. These siblings sitting on their parents. Let's put here a spread operator to move them randomly to random directions. So let's put here some distances, and those particles have been moved. Let me change the color. Yeah. So they are moving in this range. Maybe it can be a bit more. That's no, not 3.3. And what's left is to to connect these 2 points, the parent and the child. Let's create a spline operator again, spline path, and instead of default trajectories, we will choose siblings. And in the siblings, let's create a new spline. And this is what we are naming as, again, I cannot remember this word, pity all. And yeah, it's been created. So from now we can just add shape operator to create leaves. This is easy. So in the shape mesh, we change to 3D and check what we have. Of course, later you can create your own leaves and put them here in the list. For now, I'm gonna use just a leaf shape. Nicely looking maple shape. We don't see anything because we need in display change to geometry. And we have the leaves. The leaves now are oriented from Lee. We will fix that in a minute, but let's just fix the scale first. They are too small. Let's make them bigger, maybe like this. And variation can be 15 is okay. I think I reduced too many leaves. In this spawn, no, here, spawn by travel. Let's bring back this number. And step size can be bigger. And spawn not 50%, but to spawn 85. Alright. Alright, now what I want to do is to give the proper orientation to these leaves. We can drop here the third event, rotation, and from random 3D we will change to align to parent. Yeah, let's see. All right, for example, here or here, it's oriented correctly according to the vector of the parent particle, but it's just flipped. We have to put here in the proper axis minus 180, and this is done. All right. Let's select our spline and enable the mesher. See the tree. Let me disable display in dots to have clear view. Yep. Yeah, we can change the color. Let me switch from performance to standard and change quickly the viewport colors of each part. Yeah, TyFlow the TyFlow object will colorize the leaves. Actually, no, display here will colorize the leaves. So we need to change here. And these parts these are splines, so we can change them from here. So here's your tree, and we can adjust many things here. First, what I found really nice and cool, we can, in the birth operator, the first one, we can change the seed. and it will recalculate everything. So you will have a new look, but still having the same height, structure. Yeah, I think leaves are too small now. So in the shape, we can change to 300 maybe. We can change also the force, the noise, make it scale smaller and maybe stronger the effect. In the branches we can change the depth to increase amount of branches, make it more dense, and maybe we can change the angle, so how branches are angled according to the ground. So let's say 90 will give us these weirdly looking straight lines. Of course it's not gonna work, so let's put maybe 60, oh, not 6, 60. Yeah, this is not looking pretty, so maybe 50, and change the seed. In the force we also can change the seed. The height is changing from time to time because the forces are affecting our initial particle that builds the main trunk, but this is not critical. Thanks for being here, for your attention, and I hope you will use this in your work. And let me know if you have any questions. See you in the next one.